Distance is a summation of length segments with answer listed as a number and a unit. For example, 9 miles. 9 is the number and miles is the unit. Displacement is final position minus initial position relative to an origin O point, with answer listed as a number plus a unit plus a direction. For example, 1 mile west. 1 is the number, mile is the unit, and west is the direction. So one critical piece between distance and displacement is the fact that displacement includes direction. Let's take a look at an example. Here we're looking at a person that is walking 2 miles north, then walks 2 miles east, then walks 2 miles south, and then walks 3 miles west. We would like to know the total distance. Distance is a summation of the length segments. Therefore, distance is 2 plus 2 plus 2 plus 2 plus 1. The total distance is 9 and the unit is miles, so distance is 9 miles. Let's take a look at displacement. Displacement doesn't care about the path. Displacement only cares about the final position and the initial position. The final position is at -1. If the origin is at the center of the north, south, east, west axes, then the final position, which we will call x final, is at x final equal to -1. So then their displacement is equal to the final position minus the initial position. The initial position we note by x sub I. And in this case, the initial position is the origin. So we can solve now. The displacement, d with a vector symbol, is equal to x final, which is -1 miles, minus the initial position, or the initial displacement, and that is 0 miles. So the answer is -1 miles. The displacement in this case is -1 miles. Another way to say this is that the displacement is 1 mile west. Or you could say the displacement is 1 mile in this direction. And the reason why I can put an arrow is because I have this graph already shown where an arrow to the left is indicating west. So one of these three answers is acceptable along with this diagram.